In this final installment, covering the server, we'll go over the service classes and the final entity representing the content creation. The content collection is an oversimplification of the concept. A site like Netflix would probably generate this data dynamically based on user viewing preferences and complex heuristics. I just hard-coded an entity which was simpler. The service class doesn't do anything other than create the built-in data and implements the basic service call. The content collection starts similarly to the other entities. Again, it uses a UUID as an identifier. At the moment, we'll only have one content collection, but in theory, there can be as many as there are users. The lead content represents the show that appears on the top of the UI. In this case, it's the Stranger Things header. These represents the rows of content below that. They contain the popular, recommended, and personal list of shows. Next, we have the method that returns the DTO. Since all lists are effectively lots of content, we use the same method to convert everything. Again, we make use of Java 8 streams to get all the DTOs from the list by invoking the getDTO method on every element. Now we're getting to the web service code. We're using the request mapping attribute to specify that this is a web service on the video path. The REST controller attribute designates this as a simple JSON API, so a lot of common sense defaults follow. For instance, response in the body, etc. Notice the all-args constructor. This means the class has a constructor that accepts all arguments, no default constructor. This is important. Notice the final field for the video service. It's passed via the constructor. Notice that the video service doesn't have the auto-wide annotation we usually place for beans in Spring Boot. This is called constructor injection, and it has a few advantages. Normally, it's a bit too verbose as we need to maintain a constructor with all the injected beans, but in this case, Lombok makes it seamless. In other words, Lombok and Spring Boot inject the video service bean pretty seamlessly for us. We only have one API in the server. It returns the content JSON. A more real-world API would also have authentication, identity APIs, and maybe a state querying submitting API. For instance, view position, statistics, etc. But those are relatively simple and were covered by other modules here, so I'm skipping them for now. The service class is similar to the REST API class. I used the required args constructor, which is effectively the same as all args constructor in this case. It creates a constructor for all the required args, specifically all the final fields. This again works for creating constructor-based injection. This class is also transactional as it accesses the database. We need access to all the repositories to create the entities. This is a simple utility method to read bytes from a stream in the class path. Notice the usage of the @cleanup annotation from Lombok and Apache's IOUtil API. PostConstruct is a feature of Spring Boot that lets us invoke a method after the container was constructed. This is effectively a constructor for the entire application. Here we can initialize the app with default data if necessary. Notice I throw an exception here since I assume this method won't fail. It's the first launch, so it's core that it succeeds. It's pretty easy to detect the first launch. If the database is empty, the count method on the repository will return 0 elements. In that case, we need to initialize the database. In this large method, I set up the initial data in the database. I prefer doing it through code rather than manually populating the database and providing a pre-filled one, as it's easier to do when working in a fluid environment where you constantly wipe the database. In this case, I just take the hard-coded images and get their byte array data. I then create media objects for all the thumbnail entities. The rest is pretty self-explanatory. Eventually, all the videos are created and all the media entities are added. Notice the URLs are to an external video sample site I was able to find online. This is consistent with the way a video site would work. Your actual content would be hosted on a CDN for performance. Also notice I didn't get into the whole process of encryption and complex DRM streaming. That's a whole different level of complexity. Finally, the last bit of content is added to the content repository and everything is saved to the database. This is the entire server API. This returns a JSON structure used in the client. We could stream this in smaller blocks, but that was already covered in the Facebook demo, so I skipped it here. Thanks for watching. I hope you'll enjoy the rest of this course and find it educational.